agents do transactions on your behalf, but you receive a notification on your mobile to either approve the fund flow or reject it, just like Google or GitHub authentication. ProxyKey lets AI agents transact on Casper through user-owned mandates instead of user-private keys. AI agents are becoming capable enough to discover opportunities, call APIs, and trigger transactions. The problem is that today's wallet model was built for humans clicking buttons, not autonomous agents. Giving an agent a private key is too dangerous. ProxyKey solves that by turning agent actions into user-owned Casper mandates. ProxyKey is a Casper-native mandate layer. An agent can request authority, but the user keeps custody. The user can fund a vault, approve one-time or delegated mandates, cap spend, restrict the target service, restrict the resource hash, and revoke authority later. The agent never receives the user's private key. On the agent side, ProxyKey exposes an MCP server. This lets an AI agent interact with Casper authorization infrastructure without handling the user's private key. The agent can register identity, stage an intent, explain the approval, check the mandate, and index finalized execution. All the agent's intents, whether they are pending or approved, gets listed here, like a mobile notification which hits when agent register the intent. And once the intent is confirmed, agents finalizes a mandate, and once the user signs it, basically it's the approval that agent gets the green flag and can now do whatever with the amount signed under the mandate, whether through X402 payments or other methods. This is the user-controlled vault. Funds are not handed to the agent. Vault is the source of mandate-limited spend, and the contract enforces how much can be used. Reserved balance means capital is locked for active mandates. Available balance means the user can still withdraw or allocate it. This deposit is a transaction through CSPR.click. The API indexes it after the finalized transaction matches the expected ProxyKey deposit session WASM and runtime arguments. The verifiable transaction receipts gets registered here by the agent whenever it spends the allotted funds of any mandate to make the fund flow auditable and trusted. I have ran the demo prior to keep the video short. The demo use case is RWA risk data through an X402 style payment flow. The agent asks for a tokenized treasury risk report. The service responds with HTTP 402 payment requirements, network, payment amount, settlement account, and resource hash. The agent now knows what it wants to buy, but it still cannot spend user funds without a mandate. We can walk through all the MCP calls the agent made, like registering itself as an agent, then registering intent to use funds and mandate for the same, and then waiting for the user to once sign so it can go on with its flow without any interruption. The agent stages an intent. The user, agent, target service, requested action, spend amount, resource hash, payload hash, and nonce, all in a structured request that can be verified on-chain and indexed for the user. Before the user signs anything, the user sees the risk boundary. The agent cannot execute until a mandate exists, and the mandate can cap spend, target, resource hash, and expiry. The user sees the pending agent request in the approval inbox. The important part is that the user is not signing over the private key. The user signs a Casper mandate. This agent, this target, this resource hash, this cap until this expiry. After approval, the agent checks the mandate. It can see that authority exists, but it still only has authority inside the mandate scope. If the agent tries the wrong target, wrong resource hash, too much spend, replayed nonce, or expired block, the contract rejects it. And we can see the whole executed lifecycle of the agent funds flow and contract calls here. All the contract calls are in the same sequence as the agent had done the execution for user in the IDE through MCP calls, and at the end, destination payments spent over X402 HTTP protocol. ProxyKey turns Casper into an authorization layer for the agent economy. Agents get the ability to act, users keep custody, and every action is capped, scoped, revocable, and receipt-backed. The first use case is RWA times 402 payments, but the same mandate model can extend to DeFi rebalancing, DAO execution, treasury workflows, and agent-to-service commerce.